to make the introduction, Peter?
Sure. So our today's Pau Hana is going to look at a biomass company, HEXAS, which has developed a proprietary grass product that offers a number of benefits. One being a source of sustainable fiber, which can be used as a substitute for wood products and as a feedstock for energy production. Wendy Owens is the CEO and founder of HEXAS, and she's going to do the presentation for HEXAS today. Background, she's an entrepreneur with experience across a number of domains, which combines a background in materials engineering and biotechnology. And I think something she shares with all of us, a love for the planet upon which we live. She spent 14 years as an executive level appointed advisor to the U.S. Secretary of Commerce and also as a U.S. trade representative. She's written on a number of subjects and earned a Master of Arts degree from Tufts University. So as we get going, maybe we can all introduce ourselves to each other. I think a lot of us know each other, but I'm Peter Sternlight. I'm one of the board members at Sustainable Energy Hawaii, and very, very happy to welcome you, Wendy. Mitch, you want to introduce yourself?
Yeah, Mitch Ewan. I'm with the Hawaii Natural Energy Institute, and I operate a hydrogen station on the Big Island supporting 3 hydrogen-fueled buses for public transportation.
Nice.
Looking for hydrogen.
We can do that. I'll talk about that.
Good.
Excellent. John, Carol?
Yeah, I'm a research agronomist based on the Big Island, but I also spent some time here in the mainland. I've got a long experience in Hawaii ever since from the late 70s, building the first refrigerated avocado packing plant to current projects now are plant-based energy systems. And yeah, so that's what I do, and currently involved with that.
And Jerry?
Hi, I'm Jerry Chang, former state representative and a member of the board of SEH.
John Cross?
John Cross, former sugarcane manager on the Hamakua Coast. I'm very familiar with banana grass and other energy grasses like this Pennisetum, and I'm really looking forward with working with Olson Trust and Troy to get this grass growing and turn it into cattle feed.
Russ, you're muted, by the way.
Hi, Wendy. Russ Kohler. I'm the president of the Association of Energy Engineers Hawaii chapter. And I went to school not far from you at Maine Maritime Academy.
Nice.
Troy, you're up.
Aloha. I was invited by John. My name is Troy Keolanui. I'm the Chief Agriculture Manager for the Olson Trust, and very interested. I have met Wendy before, and you know, we're looking for what that next crop is. We want to keep the land in ag, and doing so in a sustainable, manageable, feasible way is super important to us. Mahalo.
Excellent. Let me see, Noel.
Hey, Wendy. I think we may have exchanged notes here, but yeah, board member for SEH, also involved in a number of local nonprofits focused on sustainability, climate, and resilience. And I'm infrastructure partner for Sustainability Partners. We're a public benefit corporation investing in critical infrastructure with the state and county here in Hawaii.
Great. Thank you.
Paul?
Hi, Wendy. Paul Pontio. I'm the director of Blue Planet Research. That's our lab in the background. Also very active in the hydrogen community here with Mitch and others, and I'm very interested in the grass. Smells like Hanua Ola, so could be a nice replacement for the trees.
Yeah, yeah, we've talked with them. Yeah.
Gary and your puppy.
Hi, Wendy. I'm Gary, and this is Louisa. I'm a
Hi, Lisa.
regenerative farmer. I'm a regenerative farmer here in Curtistown. I raise plants and animals, and am passionate about trying to figure out if we can introduce a farming system which aligns planetary and human well-being to recapitalize the planet.
You're preaching to the choir there. I love that, Gary. Thank you.
It's an amazing place he's got, and if you have a chance to go visit, you should. Keith.
Aloha, Keith Neal, long-term interested in energy and food. 35 years in engineering and aerospace. While doing that, I took an interest in sustainable aviation fuels, and had an opportunity to attend several algal biomass organization, get-togethers.
Nice. Nice. What do you think about the algal stuff?
Promising. Again, if you're making lipids, to burn them is the least value. You could turn them into food, pharmaceuticals, nutraceuticals. But very interesting.
Yeah.
Very cool. Sydney, your last up. Thank you for joining us.
Aloha, Sydney Higa. I'm with Holu Holdings, and I also sit on the board of Renew Rebuild Hawaii. I'm interested to hear what you have to say, because we're very interested in what kind of products could be brought here to Hawaii that would substitute for imported products, and then what kind of products we could manufacture out of this for an export to help our economy out.
Great. I think we had someone else join.
Yeah, we did. Kristen Senda has just joined us. And let me see. No. Okay. So Wendy, I'm making you co-host so that when we get to it, you'll be able to share anything that you want to be able to share on screen. Sure. Kristen, if you can hear us, you want to introduce yourself?
Sure. Hi, I'll turn on my camera too, briefly. Hi, everyone. I'm Kristen.
Hi.
I'm from Hawaii Gas. Julie Yunker shared this invite with me because she couldn't make it. So sorry for being late, but happy to be on.
Yeah, welcome. You missed the introductions, but you'll get the good stuff. So Wendy, why don't you go ahead and take it away?
Well, first, mahalo. And I want to say hi to Troy, because he's such an amazing partner to us, and aloha to everybody. So I am the founder and CEO of HEXAS Biomass, work with John. We really just have a goal of making the highest and best use of natural resources, first off. And I started this company actually developing the technology about 6 years ago. We started commercialization probably 2 years ago. And before that, we were just pulling things together. My background is in advanced composite material engineering. And then oddly enough, that led me into biotech. And that's what I did before I started HEXAS, and this is my fourth startup. So maybe I'm a glutton for punishment, or I'm someone who just wants to find a way to do something good in the world. And so I decided that after the kids got just old enough for me to start being an entrepreneur again with the demands that requires, that I wanted to do something to work for the earth. That was the bottom line. And I felt that the best way I could do that is to hunt for something. I actually came across this grass through a friend, and it was a wild type grass. And I said, no, we can make it better. We can do it so that we're not having any seeds or any invasivity issues. And I want to introduce you to the grass, which we call Xano grass. And what we sell at HEXAS is called Xano fiber. So we take the fiber. I'm going to focus on the use of the fiber specifically for energy in this presentation, though you'll see in one of the slides that we have tested it and used it in quite a few other products. So to the end, the Keith, that you were talking about alternative products, We have made hybrid fiberboard with IKEA. We've made oriented strand board and so forth, but I was going to focus the time that we have together on potential energy applications. And then also talk about how we have a single fiber, but how we can get multiple products out of that single fiber through processing. So I'll hit on that because I think what John and I talk about often is how do we make the highest and best use, but also get the best ROI. And so necessarily burning something maybe not be the highest best use, but if we get something out of it before we put it in the burner, perhaps that's the most effective and efficient use of the resource. So I have a little presentation, it won't take long, and then I look forward to questions. Is that okay, Peter? Does that sound good? All right, great. Okay, so I want to bring that up. All right, so we talk about providing nature-based substitutes for wood, food crops, and fossil fuel-based raw materials. So essentially, we're a raw materials company. And our goal is to do better than this net zero that people keep talking about with carbon, because that's not going to get us anywhere. Net zero is just not going to swing it. So we are working towards a carbon negative in everything that we do. And with this grass, our goal is to recover, replace, and reclaim what the earth has lost. So really rebuilding what we've lost through over farming or just abuse of our own environment. So we're disrupting the use of different fossil fuels that may have higher profiles, whether methane production or high greenhouse gas production. So we want to leave trees standing, we want to leave farmland for food and not fuel, and we want to leave fossil fuels in the ground. So what we produce, again, is called xanofiber. We can grow it in the stalks I'll talk about, and then convert the material itself either physically or through biochemical processing into different products, textiles and paper and energy pellets and chemicals, and also biofuels. So it does look like corn and bamboo had a baby. It does have these big corn-looking leaves, but a bamboo-like looking stalk, actually in the same family as both. So we're taking the best benefits in terms of corn because we have just as much corn, just as much sugar within our stock material as corn stover. And we produce 12.5 times more biomass on a per acre basis than you would with corn stover. So much more land use efficient. So we can grow all around the world. I say not on the side of mountains, and John doesn't want us growing on a grade that's over, what says you say 11 or 12% today. And we can grow in multiple different climates and soils. We're currently growing in Hawaii with Troy at OK Farms. So this is a perennial crop. It grows for 20 plus years at a time. You put it in the ground just like your front lawn. You take care of it a little bit and it's going to grow every year. And we're growing on marginal land. So those soils, which I'll talk about in a minute, that are just no longer can be used to produce food, that's been over farmed or over mined or over something. This plant will actually grow there. And during the process of growing there, it will actually renew that soil again. Very low water use, no pesticides that we have found as of yet that we need at all, and very resilient to weather events. Very high moisture content. So we're not going to see this grass ever dry out. So we're not going to see it as a real fire hazard, which I know is an issue in Hawaii, having seen the tragedies that happened there recently. And we really put a lot of carbon in the soil. So when we look at this plant, the nice thing is that this is a yield in a very temperate climate. So certainly not in Hawaii. We're going to get at least twice that in Hawaii and a per ton basis, dry per ton basis per acre. But it's an EPA approved bioenergy crop, which means there are actually monetary incentives for using it. And we produce just so much more biomass on a per acre basis. It's just land use efficient, and we can grow close and locally. And that's what I think is really important to island locations, is that we can grow right there locally, but on as little land as possible to get the most biomass. So the way we look at it is this: when we look at marginal land, we have this, let's just call it dirt, right? Nothing more than dirt. And we've been growing in dirt essentially in California for a while. Nothing there. But we plant our plant, and that's put it in the ground, and we start seeing it develop a symbiotic relationships with the microbiome in the soil. It's adding nitrogen naturally to the soil. It has a very deep root system, breaking up hard pack, making the water holding capacity rise, and putting carbon high, not only through the microbiome it circulates through in terms of its life cycle, but also through the root system, very deep down. So we get more of a carbon permanence, and that's just so important. And John's taught me a lot about carbon and needing that carbon in the soil. We also get the leaf litter that layers the top of it. So we're building up topsoil, and that also is also building up the carbon. So when we look at the plant and we dig it up out of the ground, we see this amazing root system. So this is about 4 months old in our site at a USDA research farm in Arkansas. And you can see the incredible amount of roots that are there. So that's all capturing carbon. It's holding that soil together. And the little white things that you see actually look like underground flowers, but that's the stalks that will eventually come up, the tillers that come through the ground. And it makes this really nice crown, and it grows just like your grass in your yard, and eventually will reach terminal density and just continue to grow. So we can scale this pretty straightforward. There are millions of acres around the world, that are available for use, but cannot produce food crops. Again, so abandoned cropland, just abandoned cropland alone around the world is 83 million hectares. That's 203 million acres. It's a lot of land that we need to restore and rejuvenate and make usable again, either for food or for rewilding. So there's just a lot out there. And we've been developing an app under one of our grants that we have, our Department of Energy grant, to actually find the best siting locations for our xanografts. We're using all off-the-shelf harvesting, production, and planting equipment. So we're not having to make people change their light fixture to use our light bulb when we contract with farmers for production or we produce ourselves. So let's talk a little bit about energy, bioenergy. We'll focus there. Again, we can use this product to make other things, and we can supplement, whether it's agricultural waste or municipal solid waste, of course, and so forth with this product and other applications. But let's just talk about that real quickly. When you look at what makes a good feedstock, and so having worked on this now for the past 6 years and looking at what is the criteria when people really want and really need, everybody's got a process. They think they are agnostic. They can throw anything in there. Not the case. You need a low-cost feedstock. You need consistent properties. You want a reliable supply that's available year-round, even in temperate climates, which we are because we can harvest pretty much on demand, as long as you can get the machines in the field. It's available everywhere locally. So as you move around the world and you want to establish different hydrogen production through pyrolysis facilities or ethanol facilities or something else, you really would not, it'd be nice to use the same feedstock all the time. It's not food. Right? We're avoiding using food because we're avoiding using food arable land, right? We can use it in multiple application. It's a drop-in solution like I talked about. So when we format the nanofiber, it's formatted to drop into existing manufacturing capabilities or existing energy production capabilities. It has the right biochemical and thermochemical properties because that's an issue, right? So rice straw, it has very high in silica. That's super, super tough just on your conveying and your hoppers and things like that. We don't want that high silica. We want something that hits that sweet spot in a minimized carbon footprint or carbon negative, and then qualifies for green incentives. So when we look at the bioenergy possibilities, we're looking at biofuels, direct combustion, anaerobic digestion, bio-oil, hydrogen, and we want to meet everyone's sustainability objectives. I know we talk to these big companies and they have all these great objectives and so forth, and it's a little bit of talk, but if we can be part of the solution to help them meet those objectives, that's our goal. So we've tested in the biofuels through fermentation, gasification, hydrolysis, pyrolysis, to convert this biomass into these very different fuels. We've been working with the National Renewable Energy Laboratory on a Department of Energy grant that's specifically focused on sustainable aviation fuel and optimizing our fiber so it can go into these existing alcohol to jet pathways or the approved pathways that are out there. We also got to put in a grant with NREL and Shell on biopropane. So we've been working on a lot of different things. So in terms of production levels, let's just think about, okay, if we were going to take this, we were going to just simply turn it to ethanol. Neither John and I's favorite application, but for demonstration and comparison purposes. Because we produce so much more biomass, so much more efficiently, we can produce a lot more ethanol on a per acre basis than these other products. So we can go into, and from an EPA perspective, they're saying cellulosic jet fuel, cellulosic diesel, heating oils, naphtha, et cetera, But we just are more efficient, and that's what we really want to do. So, you know, standard process. We worked with the National Center for Ethanol Research and processing the xanofiber, and it worked just like corn stover. It was great. Then otherwise, direct combustion, in replacing wood. So this is a direct replacement, substitute, or co-firing biomass for wood or for coal. So we have a lower ash content, we have a high heating value, and we can achieve the bulk density and also the durability of the pellets that we produce from this fiber. So just a little mention here, more staff with less biomass. We're talking to a lot of companies. We're talking to folks all over the world about how do you find a biomass that is low enough cost that fits into these systems that they've put together. So for example, one of the things we're doing with Shell and NREL is we're developing a biolubricant product. And so someone mentioned lipids earlier. We are working on, yes, making a higher and better use of the lipids, and then also having a high concentrated protein extraction. So when I talk about this opportunity for multiple products, we can look at xanofiber from the perspective of if we put it through, for example, a steam explosion process, which we'll be testing in January with a company we're working with that has a new steam explosion plant in Louisiana, we can end up with all these different kind of products here. So we can have a sulfur-free lignin, we can end up with the fermentable sugars, we can end up with the cellulose, hemicellulose products that can go into pulp and MDF and so forth. So I look at it from the perspective of the idea of using the whole buffalo. You know, how do we grow it once and get lots of products out of it? Because that's what they're doing with fossil fuels, right? They're pumping it out of the ground, they're refining it in everything from crude all the way up to petroleum jellies. How do we also do the same with biomass to be extremely efficient with it? So a little insight into who we're working with and have been working with and have support from. These are the different areas that we have been doing some work. Fiber boards with Roseburg, IKEA, and we're developing an oriented strand board product with another big company out of the US. We have Comstock. They're a great company out of Houston. They use a combination of biomass and also tallows and fats and oils, and they end up with 1 ton of our xanofiber ending up with 1,000 gallons of what is a precursor oil. It's like an ethanol, but it's a precursor that can be converted into biodiesel, or it can actually be converted into kerosene for jet fuel. Hafner Energy, we're working with them. They have a great process for hydrogen production. It also creates a bio oil through pyrolysis, and they have a biochar. So there are actually 3 products that going through their process that we can convert. And so we have an agreement with them on that, and to help them, wherever they go, we go kind of thing. Shell, we've been working with obviously in the biolubricants, and then we have a couple other companies that I'm sorry I can't disclose at this moment, but we are working in biocomposites as well as in biochemicals. So when you break that sugar out, there's so much that you can do with that sugar from the biochemical perspective, and even bioplastics. Pulp and paper, well, we're looking into that, not our big focus at the moment. Textiles is something new. We can, the U.S. Department of Defense wants to onshore all of our textile manufacturing. So we're working with one of their nonprofits. We can turn this into a viscose, which is the rayon, like a tencel material, because of the high cellulose content and high quality. And then we have support from LanzaJet, Boeing, and BP for our different grants. So where we're growing, or where we will be growing in the next sort of 9 months, Washington, we're looking at Nevada, Texas, Arkansas. We're already in Arkansas, but Louisiana. Over in Australia, we actually have our plants in quarantine there. Once they get out of quarantine, we'll start planting. We've been growing in Hungary with IKEA, and of course, OK Farms, and that's been a wonderful relationship that we have there. So I want to end and say that I didn't get into this for the money. I got into this to make a difference. And John and I talk about this all the time. How do we really have the most impact? And I put these 4 up here just as exemplar because the UN uses these. But we want to make sure that anywhere we go to plant this crop, whether it's 500 acres or 10,000 acres, that we are doing the right thing. We're not repeating the historical problems of the past that happened with monocropping and wanting to just drive everything you possibly can out of the soil and out of the earth. So we take this very seriously. We're doing an ecological study right now in Arkansas with the University of Arkansas of what animals use xenograss as home. And, are we chasing away any animals because, we have this new crop there. So we're taking this all very seriously. And I want to know that you to know that we take Hawaii very seriously. It's John's other home. And though I've only been once, and I can't wait to be down there again very soon, I appreciate your time and your interest in what we are doing. So thank you so much. Mahalo.
I had no idea. This is yeah, no kidding. That was really pretty amazing. I'm sure there are questions that or comments or thoughts that other that people have. I know Gary's going to have at least one.
I'm sure. I know. I'm sure Gary is. I was going to say, and I wanted to say to John Cross, John, we do have that cattle feed grass that I didn't address in this presentation. You're absolutely right. We do have that as well.
That's you're talking about the pennisetum?
The pennisetum that we have, that special one that we ended up with. Our test showed, John, was it 19% crude digestible, somewhere around there?
Right, and that's what really intrigued Troy and I about replacing the alfalfa pellets and alfalfa imports into Hawaii. Can you believe how many containers are coming in to Hawaii with alfalfa and timothy grass and all these pellets? We can grow it right here. We can feed our own dairy cows and horses and sheep.
Well, this grass, John, this grass is actually 26% protein. So you know that's super optimal for beef production or for butter fat production. However, if we're going to use it for equestrian use or something like that, we would put some of our regular grasses, our native Hawaiian grasses, mixed in with that just to reduce the protein content. So it becomes very flexible. But the interesting thing is it's very palatable. And it produces such massive amounts. It's relished by swine, by goats, by sheep, chickens. It has such a high protein content that it's just extremely effective.
That's what we call ali'i grass, and not the xenograss, but the xenograss has some protein to it too. But yeah, John, maybe John Cross, that's another thing
that's a topic for another time. Yeah. This is a different grass, and it has distinctly different uses. And yeah. So
there we go, Mama. Nice.
The xenograss is very suitable because it can be cut and it can be dried in the field. And in our Hawaiian conditions, we can take a plant at 70% moisture content and have it down to 11, 12, 13, 14% moisture content. So it makes it easy to turn it into a pellet. And we can use that pellet for thermal conversion or for co-firing with coal or as a standalone fuel to run a turbine. We can also use that plant. It has a very large amount of methane production. So it can go into an anaerobic digestion system as a sole feedstock. That methane can be conditioned and it can literally be used as natural gas. Or it can be used to power a turbine, and that energy used to create hydrogen. It makes structural panels. There's a multitude of uses for this very unique grass.
Is it currently grown in Hawaii?
Pardon me?
Yes.
Is it currently being grown in Hawaii already?
Yes.
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 Is it considered an invasive species according to Department of Ag?
No.
So it went to the agriculture.
Oh, Jerry, sorry, you muted yourself.
Sorry. Did it go to the Agriculture Research Center process for approval to be grown in Hawaii?
So it's been grown in Hawaii, John, you want to talk about how long it's been in Hawaii?
Okay, so it's approved through the Department of Ag in the United States as a biomass plant. And it's been proven that it's non-invasive, it doesn't produce seeds. And it's the type of plant that if you plant it in the wrong area, it can get away. And the only way it can get away is through mechanical action. But if it's planted in a field, it doesn't migrate and it stays there. The areas where I collected this grass, it's been in the same location for probably 40 years, and it has not moved more than a meter from its original planting. So it's pretty interesting.
Yeah.
And Hark, you know, I've grown a lot of plants out at Hark over the years, different biomass crops. This is not one that I have grown with them. And it was one that we were going to introduce for the Aina Ko'opono project. But it's a very special plant, and it requires, I didn't want it to escape.
Yeah, it's
into other people's hands.
We've had no trouble. I'll just show you a picture of one of our fields that's been around for 5 years. And you can see it colors between the lines. It just stays there. We've never had any problem with invasivity. Again, it's sterile, no seeds, and the only way you can propagate it is vegetatively. So consequently, there's just no way that it'll release. If it's chopped up, you're not going to get anything, a propagal laying anywhere. So we've had no troubles with that too. And it's approved in Australia. We've already been growing it in Europe. So we've had those approvals as well.
When we propagate this in Hawaii for large scale production, all the plantlets will have to be tissue cultured.
Right.
Because it is very, very difficult to propagate it through cuttings or root divisions or any of those things. So it will all be done through tissue culture. So everything will be virus indexed and yeah, very consistent. The genome will be consistent.
So you'll be selling the tissue culture?
No, that's not our business model. So our business model is to either lease land for production, or our preference is to work directly with farmers to give them an alternative revenue generating capability on the land that's not producing any food. So a lot of farmers we've talked to, and the farmers we're working with over in Europe, for example, they've been just producing hay on that land, but they get a much higher price per ton if they're growing xano grass instead. We own the above and below ground biomass because we can take that biomass up and repurpose it elsewhere. So it's a nice contractual relations. Our farmers just kind of let the grass grow, so to speak. So.
Yeah.
Got a great partner in OK Farms.
Yeah, absolutely. Neil, Noel, you had a question, Noel?
Yeah, I did. I think it was partially addressed. I was curious about propagation, how that will take place. It looks like it's already been answered. Curious about the so it's clearly a I don't know if the right word is bioengineered plant, right? Or is it
selectively bred? So we've been very careful in selecting different. We have several different varieties.
What is the actual basis? Like what's the actual underlying grass that has been?
It's like a Phragmites.
But
it's and what it is it's not propagated by seeds. And we have a very strict policy about no genetic manipulation.
Right.
So if it's propagated by tissue cultures, then it's going to be the same thing that we teach at UH as far as aseptic micropropagation. Same thing that we produce orchids.
Got it.
You know, so very, very basic propagation. And what it does is it allows for large amounts, exponential numbers to do large acreage. We need approximately 4,800 plants per acre. So if we're going to do multiple acres, we want to be able to generate a lot of really nice plants. And depending on the end use, we may have a denser planting. So if we're going to use it for biomethane, then we may do a double row system, and we have a higher density because those plants will be harvested at maybe 6 or 7 feet every 4 or 5 weeks. Whereas if it's for fiber, we want it to lignify, get much bigger. So maybe that harvesting cycle will be every 8 weeks to 4 months.
Okay.
But the interesting thing is, it doesn't come to fruition like all at one time, like mango season or lychee season. This can be harvested year round at any given time. And it stands in the field without degradation. So you can go 2 years without harvesting it and then go in and harvest it. And you will not have lost that material that was grown. It won't degrade. So it's very interesting how this works.
Wow. Thank you. I have just one other question related to the comment about hydrogen production. Is it primarily via the energy or the electricity can be generated through the biomass, or is there a pathway through biogas?
So it's a biomass pathway that that Hafner Energy has. So they take biomass or biomass waste and they put it through their process, through a pyrolysis process, and then that generates the hydrogen, but also the bio oil as well as a biochar. And we're just doing actually the same thing with NREL right now. And I'm meeting with them John and I are meeting with them next week to get their results on that as well. So
thank you.
Yeah.
However, it can be the old-fashioned way of creating steam and using the excess power to generate hydrogen. I mean, that works also much less efficient, but it's a feasible way to store the additional energy, because if we're going to have like a methane digester, that's going to be producing consistent power 24/7. So, we had talked about the last meeting we had were about these unique batteries. That's a method for holding power. But like I say, just generating hydrogen is also a very easy way to store that power.
Keith, I think you had your hand up for a while there.
Yeah, aloha.
Aloha.
Here on the east side of the Big Island, there's mile upon mile, acre upon acre of this guinea grass, and it's former sugar, producing land. And there's a group of us kind of looked at clumping bamboo, possibly as fiber. And in some of your earlier slides, you were comparing carbon sequestration. How does I didn't see bamboo in that comparison.
And the reason is because we were comparing it to crops that can actually be harvested in total, versus bamboo, which has to be selectively harvested, or you wipe out your stands. So bamboo is a great carbon sequestering plant in terms of its capabilities, but we were really comparing it to what are EPA approved bioenergy crops that are approved for bioenergy purposes. So yeah.
Got it. Thanks.
Yeah.
Yeah, a disadvantage of bamboo is it has a high silica content. And as you know, it takes more than 2 or 3 whacks with a cane knife to sever bamboo. It's a very hard thing. It's very difficult on cutting surfaces. Whereas this grass has a very low modulus of severing.
Rupture.
So, I mean, you can cut this very easy. You can actually snap it in half with your hands.
When it's in the field and wet, when it
Yes.
dries and lignifies, that's not going to happen.
Yeah, but exactly. Whereas with bamboo is a very tough crop. And bamboo, like the vivax, the timber cultivars of bamboo that are exceptionally robust in Hawaii, they can produce approximately 12 tons per acre a year of biomass. And that's if you were to cut everything. If you selectively harvested the stuff that was ready to go so that you didn't affect the health of the stand, closer to 3 or 4 tons per acre a year. This crop is closer to 60 tons, 70. It's a massive producer. Massive. 3 or 4 times the amount of sugar cane. And we all know what sugar cane looks like.
Gary, you had your hand up. I just love to. I'm
Hey.
ready. We're ready for you.
Hey, John. Hey, Wendy. Thank you so much. I just was wondering, could you speak about the root structure of this plant and if you were thinking about introducing it in a successional situation where you were trying to jumpstart barren lands, even if it's Rapahoehoe or whatever it is, perhaps even in conjunction with other grasses and plants. Have you given any thought to where it might fit in a longer term picture where you're talking about improving the land from a standpoint of carrying capacity and microbial diversity over a longer period of time?
Yeah,
Yes, indeed.
I'll leave
Yes.
John. Yeah, let John talk to that. But yeah, talked a lot about that.
So this is really, the best pioneer species is a native species, and I'm totally committed to native plants in Hawaii. However, let's say we have a very austere situation where it's a recent or Pahoehoe flow. It's virtually void of any organic material. With just light fracturing, we can get this plant going as long as there's like 30 inches of rainfall, which is in all of Puna. I don't think there's any place I know of that doesn't have that. So we can get the plant growing. And these roots, if you've seen the pictures before, these rhizomes are very tenacious. They will begin the fracturing process, and they're almost as tenacious as ohia roots. So they get a good grip and they start fracturing the lava. And basically what's happening is the plant is completely infiltrating carbon. This produces more carbon to the subsoil layers than any other plant I know. And so as the soil is, as this rock, this aggregate is increasing carbon, there's acids formed by the roots and these basalt particulates are being broken down into soil particulates. And as that happens, then there's more surface area for the microbes to colonize. They're utilizing the carbon in the soil because, these microbes are all carbon based. And what's happening is there's a source of carbohydrates and nutrients that are leaching out from the roots. So it develops a pioneer ecosystem. And once that's established and there's a residual of carbon, and there's microbes, and there's the fungal components and the mycelium components, then that paves the way for the secondary colonizers, like let's say an alpaca, or some of our native grasses, or some of our native bush species. But what it does is it supplies the initial nutrients for a diversified ecosystem. So that's one of the things you could do. Another thing is you could grow this crop and you could terminate it. And you could do a process called sheet composting. It would add so much organic matter to that or Pahoehoe, along with the carbon and along with all the necessary ingredients to create a soil microbe biome that now you're ready to support other types of vegetative life very effectively, because you've got the organic material to hold the moisture, you've got a source of nutrients, you've got a very diverse microflora with the fungus and the bacteria and all the soil microbes. You've got everything necessary. You're on the way to creating a healthy living soil. So,
John, could I use the grass in conjunction with, say, sheep or goats? Would it be a good primary source for them, again, in land reclamation?
So I've raised sheep here. I've raised Suffolk sheep for years and years, and we fed this crop to them. They relish it. So it's not a real high protein content, but if it's harvested when it's young, it's about 12 to 15%, which is more than adequate for sheep. But the beauty is it produces so much material that even though it's a lower level of protein, there's an abundance of it. And with sheep, they can get away with a lower level of protein as long as there's a quantity of material to eat.
And will they graze it while it's standing, or do you have to harvest it for them to
Okay,
graze?
so the problem with this is with sheep is they like to work close to the ground. So we have these meristematic tips when you refer back to that picture that we saw of those like little white bulbs coming out of the ground. That's where these shoots initiate. If you nibble at that when it's young, the meristematic tissues are very close to the surface. And if you eat that meristematic tissue, that's the building blocks for the rest of the plant. So sheep can literally eradicate this crop in about probably 10 months. So the best way for sheep and the best way to grow these tropical grasses, we're finding out now, is not a pasture method or a short rotation method, but a cut and carry system where we focus on growing the grass and then we harvest the grass and we feed that directly to the animals. And that way we have a very uniform crop. It's harvested at the same time. And so it comes to fruition, it's ready to harvest all at the same time. If we allow animals, just like with banana grass, people have tried to grow banana grass over in Kona side, and the cows will only eat certain ones, and some of them they stand tall, and then they grow tall, and then they get woody, and then they're no longer viable as a feedstock. So it takes man to come in there and harvest them all, and so that it's all uniform. So they're harvested at the peak of the moisture and the highest protein and the highest palatability. And it's the most effective way to do it.
I'm sorry for all the questions, you guys, but I think it's an interesting tool. I'm trying to figure out where to put it in the toolbox. Do you think if you were to propagate it in conjunction with another variety of grasses and really do a controlled rotational grazing, you could mitigate those potential propagation problems and establish it as a long-term companion crop for other grasses?
Yes and no. The issue is this has a growth profile that is so robust that it instantly becomes a smother crop. So let's say, we have a problem with gorse up in the upper slopes of Mauna Kea. If we were to plant this crop interspersed with the gorse, within about 2 years, it would completely smother that crop out.
Let's do it.
And explain smother, John. So we're not talking about invasivity.
Well, exactly. It's just it grows so robust that the overstory will completely shade out all the light.
Right, that's the point.
So let's look at this here. We've got a big problem with guava, and we know that insecticides herbicides aren't really effective. It produces seeds. The seeds are carried high wide by the birds. So the only way to really get a handle on this invasive crop, which is truly invasive because it produces seeds and the birds carry the seeds everywhere, is to grow a competitive crop that will outcompete it, grow taller, and literally take away all the sunlight so that overstory starts to senesce, loses viability. So anyways.
And Cindy, I had a question. I'm gonna move to Cindy.
Yeah, my question is, what kind of investment from outside companies would be required in order to make it a viable product for us to turn into an exportable product?
That's a really good question. So the way we do this is we don't plant unless we have a supply agreement. And the reason being is we want to be able to, of course, pay our landowners or pay our farmers. So we negotiate supply agreements up front, and then we plant, because we want to plant a dedicated supply of this fiber for every supply agreement. So this is just not like planting trees and then if you plant it, someone will come. We, having seen what happened with hemp, that's just not the business model to undertake. So we have supply agreements with our customers, and then they have a dedicated, reliable supply of biomass that we plant, and we either grow, again, under contract with the farmers or on land that we lease. And that's what we do. So the first thing we would do, Sydney, is we really want to look for those outside customers. Let's just take, for example, if we were to make just simply direct combustible pellets that could be taken from Hawaii and shipped from one of the ports to Japan. Very straightforward. They have already told us they need 2.5 million tons a year per power plant, and they have 67 of them over there. So they would co-fire, get rid of their coal, and put this in. So that would be the steps.
Is there any model that you have that would have investment come into Hawaii to utilize it in other areas other than as a feed for livestock?
Yeah. So that's why we mentioned the Department of Energy and onshoring textile production. There's more and more that they're supporting in terms of micro manufacturing. So manufacturing for local production of textiles. There's local production of papers and pulps. There's a lot of more local production people want to do. So, whether it's building materials, certainly instead of using, we have this great oriented strand board that we're developing with a US company here, where it is extremely strong. This it's incredible how strong the material is with this fiber. And then that can be a building material that can be used for flooring or roofs. And then we have both MDF, the medium density fiber board, and particle board, which is your non-structural products for furniture or for moldings and things like that. So we've been very successful in the US in producing that, but also working with IKEA over in Europe and making hybrid products with them on a pilot scale.
Do you have any companies that might be interested in actually producing these building materials here locally with a local market so that we're not having to import it?
Yes, I think there would be definitely interest in the people that we speak. I speak with people all the time and all over the place that I think would be interested in doing that sort of micro level manufacturing. It's a CapEx question, and could we find the demand? And I think that's something that we would have to look at just in terms of the market. Is the market there? Can we do it? And what would the capital expenditure be to put that in place? But the manufacturing systems themselves for things like particle board and MDF, they're pretty much turnkey. They're well, this is mechanical stuff. It's glue and fiber, and you stick it together and go from there. So.
Excellent. Thank you very much.
Sure.
You mentioned you're working with, already in discussion with Tohonua. What's the difference between burning wood and burning this grass?
It's a really good question, Jerry. So one, wood takes decades to produce in most cases. We can harvest in Hawaii every 6 to 8 months. When you're burning the wood, you're also, when you take down that tree, you've lost that carbon sink. We are sequestering carbon under the soil all the time. And so the difference being in the calculations that were done by an energy company in Portland, I want to say Portland Gas and Electric, but I always think I'm wrong when I say that. They actually showed, and this is public information, and we can share this, that the grass would be carbon negative even after direct combustion, after torrefication. So I'm not a huge fan of burning. I think we're better off with producing a biomethane and doing anaerobic digestion or something along those lines. But there is, there's the transition, and I think it's important to consider transition from using coal and using wood pellets to using some interim that gets us off that dependency for both coal and wood.
In a nutshell, Jerry, it's carbon negative, and both systems are somewhat carbon negative. It takes a greater energy to harvest a big tree in the forest than it does a grass that can be harvested with just a tractor system. And the problem with the tree is once it's harvested, we used to believe that new shoots would come from the base of the tree, but we find out that those new shoots that develop are not as productive and they're much slower growing and the yields are greatly compromised. So now we have a field of soil with these massive stumps, and stumps are very expensive to remove out of a field. It requires a lot of work, and it has to be done with excavators and heavy equipment. And then you have these stumps, and then they have to be ground or burnt. So it becomes an issue, whereas this crop is easily terminated. This crop can be terminated just by repetitive disking.
Wendy and John, thank you so much for all this great information. I'm sure there's quite a few more questions that folks will have or have. Just a couple from me. One is if there are parties that are interested in learning more, maybe even partnerships, that sort of thing, who do they get in touch with? Would it be John? Would it be, or is it through the website, the contact flow?
They can just get in touch with me. I think happy to share. Noel, you have my email address. You're welcome to share that with folks, and we can start that process. John and I should be down there pretty soon. Part of what we're doing at OK Farms is working on our current Department of Energy research down there at Troy's site. So we can also schedule our trip around when people are available if they'd like to meet.
Excellent. Yeah, would love the opportunity to meet in person. Lastly, and it relates to your commitment to ensuring that food lands that are able to produce food are not leveraged. How is that enforced? Like, what process do you have in place to ensure that that occurs?
Well, when we talk to farmers about production, we will talk to them about their non-productive land in particular. We will look at that. We have an app that we've developed that we can get into fairly granular locative in terms of what kind of soils there, the water profile and so forth. And we can look at that land and say, well, we really don't want to take out whatever the production is for whatever food crop. We'd rather focus on this. So it's really something that we have to work with the farmers on directly.
Okay.
And we target lands like sugarcane land that can't no longer be productive. So we purposefully target those locations first.
Okay.
And yeah, that's really our goal. It's policing is up to us, honestly.
Hey, one last thing I'd like to say is this plant is a bioaccumulator. So if we were to plant this in our typical Hamakua soils that have had 100 years of sugarcane planting, this is going to absorb all the zinc, all the cadmium, all the lead, all the arsenic, all those things that were used in chemicals fertilization over the past 100 years. So it's going to increase the quality of the soil, breathe new life into it. So a lot of those soils have lost their structure and lost their fertility. We can completely refurbish those soils in a matter of like 4 or 5 years, terminate the crop, and now we have very rich soil that has a high amount of carbon that is suitable for fruit production, coffee production, or other vegetable production, or avocados, you name it. But the way it stands now, a lot of those soils, they have issues with drainage, compaction, they're alkaline, and they have a lot of toxins in the soil, which can inhibit root growth and favor the nematodes in the soil. So we can alleviate a lot of those things just by growing this crop as a remedial crop and as a bioaccumulator. So.
Thank you.
John,
Thank you, guys.
would the biomass at that point have to be removed entirely to complete the remediation process?
So no, here's the interesting thing, Gary.
Yeah.
Is during the uptake of the process, these chemicals are chelated and they're mineralized. So they're put back into a form where they're not really available into the food web. They become more inert. So you don't necessarily have to accumulate those crops and discard them, because during this process, these harmful chemicals are being mineralized and rendered into a non-soluble form, a non-available form, so that they're not toxic.
We're working with Pacific Northwest National Lab actually on the bioaccumulation for nickel and looking at that as an opportunity.
This is really exciting stuff. I really appreciate you making time to join us here. Folks, if you have additional questions, we'll share Wendy's information. And Wendy and John, during your next visit, maybe we can coordinate and have a little gathering where we can meet in person.
That would be lovely. Yeah. Thank
That
you.
would.
Yeah.
Yeah,
Well,
thank
thanks
you
very
guys
much.
for the time. Appreciate
Yeah,
it.
I know it's getting late out there. So thanks very much. Really appreciate your time. This session, Peter will edit and share on our website. So we'll have many others who will be able to benefit and learn about this interesting and valuable technology. Thank you.
Thank you.
Thank you
Alright,
very
aloha.
much.
Thank you. Aloha.
Thank you.
Aloha.
Aloha.
Aloha, everybody. Have a good weekend.